Hello everyone, my name is Fairuz Bahri, and today I'm going to present our research titled Development of a Fuzzy Logic and IoT-Based Automated Irrigation System for Water Spinach Cultivation. This study focused on integrating technology, plant science, and soil science to create a sustainable solution for modern agriculture. Let's begin. Here's an outline of our presentation. We will begin with the background and move on to the research objective, setting the stage of our discussion. Next, we'll explore the theoretical framework and delve into the methodology, including the flow process. This will be followed by an analysis of the sensors and IoT and the fuzzy logic diagram, which provide technical insights into the system. Finally, we will discuss the result and conclude with the conclusion. Let's get started with the first section. As we all know, agriculture plays a crucial role in meeting food demands, especially in countries like Indonesia. Urban farming has gained popularity as a solution to food security and economic resilience, particularly during challenges such as the COVID-19 pandemics. Urban farming emphasizes water conservation, organic practices, and technology integration, such as sensor monitoring and automated irrigation, to enhance efficiency and sustainability. However, limited urban spaces require farming methods specifically adapt to these constraints. In this context, our research aims to tackle these challenges effectively. And for the problem statement, we have urban farming addresses food security challenges and supports economic resilience during events like the COVID-19 pandemic by providing fresh produce close to urban residents and enhancing dietary quality. Urban farming integrates sustainable practices such as water conservation and technologies such as monitoring by sensors and automated irrigation to optimize crop yields and maximize resource efficiency. Limited space in urban areas require properly adapted farming methods, such as the use of effective irrigation systems to ensure optimal growth. And then, urban farming promotes sustainability through the techniques such as water conservation and technologies such as automated irrigation systems and data analysis to enhance crop yields. And the last one, adaptive solutions for urban areas are necessary for the challenges that urban areas have. This includes usage of optimal planting, mediums, and effects mitigation of high temperature on crops like water spinach. And the research objective. Our primary goals are build a smart irrigation system using IoT and fuzzy logic to improve water spinach growth, enable remote control and monitoring water spinach plant through the Blink app, and the last one, make resource management and water spinach plant growth more efficient. The theoretical framework. Our approach is built on three key components. The first one is IoT. IoT connect devices like sensors and controllers, allowing real-time data exchange to monitor soil moisture, temperature, and other conditions. This enables precise management of farming activities. The second one is the fuzzy logic. Fuzzy logic handles uncertainties and nonlinear systems, such as variable soil conditions. It processes imprecise data to make intelligent decisions, like determining optional water supply. The last one is the benefits. IoT-driven systems improve efficiency by monitoring environmental factors, conserving resources, and supporting sustainable practices. This results in better productivity and lower operational costs. Now, let me guide you through the block diagram of our research methodology. which illustrates how the system components interact to achieve automated irrigation and monitoring. On the left, we have ESP32, Water Spinach Monitoring Unit, which is responsible for gathering data about soil moisture and light intensity. This data flows to the valve and lamp control mechanism. Simultaneously, the ESP32 Water Source Monitoring Unit monitors water availability and ensures that sufficient water is present for irrigation. Both units are connected to the Blink app, enabling real-time monitoring and control through a user-friendly interface. This setup ensures seamless integration of IoT devices and automation for efficient farming. The ESP32 Water Spinach Monitoring Unit can monitor soil moisture and plant condition, control valves for the water flow, and lamp for the lighting. Valve regulates water supply based on soil moisture data. Lamp provides additional light when needed. ESP32 Water Source Monitoring Unit tracks water availability in the source and then sends data to the main system and alerts for low water levels. The last one is the Blink app, enables remote monitoring and controlling, and then display real-time data on plant and water source. This presentation showcases two essential monitoring systems, the Water Spinach Monitoring Unit on the left and the Water Source Monitoring Unit on the right. These systems utilize advanced IoT technology to efficiently track environmental parameters, ensuring optimal growth conditions and resource management. Let's explore how these technologies function and contribute to smart farming solutions. Water Spinach Monitoring Unit ESP32 process data from sensor and communicate with the Blink app. Relay modules controls water pump and lighting systems. Photoresistor detects ambient light intensity to determine if artificial lighting is needed for optimal plant growth. LCD display provide real-time local system status. And the Blink app enables remote monitoring and control. Water Source Monitoring Unit ESP32 microcontroller for processing and communication. DHT22 measures temperature and humidity. HCSR04 ultrasonic sensor for distance measurement. And then the LED visual indicator for system status. Next, let's delve into fuzzy logic applications, a critical aspect of decision making in our system. On the left, we have the fuzzy logic for the temperature sensor, which categorizes temperature readings into statuses such as cool, normal, and hot. On the right, we see the fuzzy logic for the distance sensor, which determines water levels by categorizing distance into full, enough, or empty. These flowcharts illustrate how the system processes real-time data to generate actionable outcomes. Let's explore how this logic drives smarter and more adaptive operation. The purpose of fuzzy logic distance sensor is to measure distance using a sensor and determine the status. The first process, the sensor reads the distance, and then if the distance is less than equal 8, the status is set to full. If the distance is between 8 and 15, the status is set to enough. If the distance is more than equal 25, the status is set to empty. If the distance doesn't fit any of these conditions, the system assigns to no status. And then the status data is sent to Blink app for monitoring. And then the purpose of fuzzy logic temperature sensor is to measure temperature using a sensor and determine the status. The first process, the sensor reads the temperature. And if the temperature is less than equal 20, the status is set to cool. If the temperature is between 25 and 30, the status is set to normal. And if the temperature is more than equal 35, the status is set to hot. And if the temperature doesn't fit of any of these conditions, the system assigns to no status. And then the status data is sent to Blink app for monitoring. And then as we can see, for the result, on the left side, we can see the Blink IoT user interface. And on the top right, we can see the implementation on the daytime. And on the bottom right, we can see the implementation of the nighttime. Our smart irrigation system achieved real-time monitoring of soil conditions and plant health through the Blink app. Efficient irrigation that reduces water wastage while promoting consistent plant growth. And then the last one, enhanced system performance during both day and night operations with minimal manual intervention. And then the conclusion is, this project integrates the Blink app and fuzzy logic for real-time monitoring and environmental management to optimize water spinach growth, with potential future enhancement, including soil nutrient, sensors, and solar-powered energy sources for improved efficiency and yield. To conclude, this presentation has demonstrated the integration of sensors, IoT, and fuzzy logic in developing smarter and more efficient monitoring systems. Through a combination of innovative technology and systematic methodology, we have provided solutions that can enhance resource management and agricultural productivity. Thank you for your attention and interest in this work. We hope this inspires further exploration and innovation in this field.